This is the Dell Pro Max with GB10. That's Dell's product name. This is Nvidia's DGX Spark in Dell's packaging. Dell has made some meaningful improvements, and the out-of-the-box experience from both Dell and Nvidia is top shelf if you're onboarding yourself into the new AI future and ecosystem that we find ourselves in. If you're a researcher or a student or someone that works with machine learning, this is an amazing product. If you're like home lab or hobbyist or something like that, this is maybe not the right product for you. But let's discuss its capabilities. Let's unbox it and see what you get. Let me show you some cool applications because you can immediately use this machine. You can deploy it, connect to it wirelessly, connect to it over the network, connect two of them together. Got two of these. It's going to be really exciting. And immediately have an AI agent available to you on your laptop, your workstation, anywhere you can connect to this thing and start doing meaningful work with it right away. It's pretty exciting. So what is this product? Who is it for? This is a perfectly functional, usable model of pretty much exactly the same software and hardware experience that you will have with the AI factory and Run AI and the whole suite of Nvidia and everything that they're doing from the small scale to the very large scale. GB300 NVL72, what Nvidia is deploying at scale for maximum density, like the hyperscalers. B300 solutions, like the meat and potatoes of the AI factory. This is GB10. It's all the way at the very smallest end, but the software stack is the same. That's the promise. And that is the useful experience. And it's even the same because there's this whole idea of a GPU fabric. You get multiple GPUs connected. You can connect multiple Sparks together and have much the same software experience. Now, the performance for running the AI is pretty good considering that, this is a 1 to 200 watt, depending on how much of the system is active, platform. You're running 200 watts, whereas that GB300 NVL72 rack, it's 140 kilowatts. That's a lot more than 200 watts, 0.2 kilowatts. And that's a worst case scenario. Really, most of the time, the actual compute part of it is more like 100 watts. So this is it. This is the Pro Max. This is your 1 petaflop of NVFP4 for performance. Yeah, you can get up to a petaflop out of this thing. This thing has up to a petaflop of compute. 128 gigs of LPDDR5 with up to 273 gigabytes per second memory bandwidth. It has your 200 gigabit of ConnectX-7 NIC. The ConnectX-7 is an important part of the GPU fabric. It's a high-speed interface. A mini PC with 200 gigabits of connectivity. Not just the QSFP cages on here, but also 10 gigabit wired Ethernet, HDMI. You got 3 Type-C ports plus a 4th Type-C port for power input. And those are 20 gigabit. They also support DisplayPort alt mode out. The Wi-Fi antennas, they're in the bottom here. And this is it. This is all there is. There is an upgradable M.2 internally. Shipping with this configuration is a 4 terabyte. It is not a 2280. It's not 80 millimeters long. It's 2242. So it's a smaller, more diminutive version of the M.2. That was a design choice and consideration that Nvidia made. You optionally, when you're placing your order for your Pro Max, you have your QSFP cables. You can get 1 or 2 of those. You'll only need 2 total, so if you're getting 2 Sparks, you could get 1 cable with each Spark to connect them together. You can connect a Spark with just 1 cable, but to get the full bandwidth, you'll need to use both. It's your Dell power brick. Now this is a 280 watt USB-C power brick. This there's different versions of the Nvidia Spark. Did a review on the gold one from Nvidia. Nvidia should have done a little better job with the thermals on that. And that one came with a 240 watt power brick. 280 watts gives you a little bit more headroom, so that's nice to see. Also got our power cable. That's your Wi-Fi antennas on the bottom. The magnets here, you can take the screws out to get to your M.2. You've got all of the information, the regulatory information, but importantly, you've got your network SSID and the password for getting access to the local machine. Now Dell has also put that helpfully on a sticker on the side so that you don't necessarily have to fight with the magnet to get to it, but there you go. Now, as the Wi-Fi is on the bottom, and as it is a metal case design, as with Nvidia's, I find that the Wi-Fi works better when the device is on its side. We at Level 1 Techs love our 3D printer, and we love being creative. So we made a 3D printable stand for your DGX Spark that's compatible with the Dell Pro Max with GB10, as well as, you know, the Nvidia reference Spark and all that, but that will hold them up on their side. Isn't that fun? Now, Dell's done a number of things for the just past the unboxing experience that are awesome quality of life improvements over the gold version, the Nvidia version of the DGX Spark. One of those is the power brick that Dell bundles. It has an LED power indicator on the power brick. This is fantastic. There are no LEDs of any kind on Nvidia's, none whatsoever. When I turn it on, you'll notice we also have an LED on the front. A nice, recessed, very subdued LED. It's not blinding, it does not put out an excessive amount of light, but it does make it easy to see if the darn thing is on. Good job, Dell. With mine, I get the KM900 keyboard, which does Bluetooth and RF. It has its own little receiver, wireless keyboard and mouse, and it supports up to 3 devices. This is absurdly convenient because if you have this on your desk and it normally doesn't have a monitor connected to it, you can just use this with your regular desktop computer or your laptop that's connected to an external monitor, and when you need to do something on this one, you can just switch over to it. For the initial setup, it'll ask you for your time zone, some other information, and agree the terms, and then it's immediately going to download an update because I've plugged it into wired Ethernet. If you didn't plug it into wired Ethernet, it'll ask you about your wireless network and configuring that. If you don't have wired internet or a wired network, you can use a laptop or you can join the machine as a hotspot and configure it that way. Also, it's worth pointing out, these machines come configured for PXE boot out of the box. So that's another thing that Dell does. If you have a PXE boot based asset management or inventory management or provisioning system, you can totally enroll these in that and they'll network boot the first time that they see network. And then you can provision and enroll, configure the operating system image, set the username, whatever, if you have a fleet management type stuff, which that's a really nice thing, nice feature to see. I have not seen that on the other DGX Spark implementations that I reviewed. They are not configured to boot from the network by default. The Dell is. And then once the system update is applied, it's an interactive environment. You log in and this is Nvidia's DGX OS. It's based on Ubuntu, but it also comes with Ubuntu Pro, so you have all of the Pro canonical support that you would normally get with Ubuntu, but Nvidia. And so that means that the packages, CUDA versions, all of that is already figured out for you. You don't have to install anything. In fact, you can immediately launch into Nvidia SMI. If you want to immediately deploy Comfy UI or deploy Jupyter Notebook, it's here, it's accessible, it's ready to go on your LAN. Like, the next thing is to just connect. It's like set up local network access and configure now. If you want to immediately plug this into your code editor on your laptop, the next steps is to just click configure now and it will walk you through configuring your local network access, and then you can download a model. And because this is accessible over the network from your laptop, you can connect to a model here and do code assist. Now, connecting to the Spark over the network, you can do it 2 different ways: standard old SSH and Nvidia Sync. Nvidia Sync is a really neat application that works for Windows and Mac OS. SSH works for Windows, Mac OS, Linux, basically anything. And you really, if you're not familiar with SSH, you've got a long road ahead of you, but it's going to be a fun and exciting road, and you're going to learn a lot of things, and I'm vicariously excited for you for all the things you're going to learn. Nvidia Sync is a really awesome little tray application that'll let you find and connect to your Spark, and under the hood, it's still using SSH. It's just SSH with a really slick, make it easier interface, and then manual connecting with SSH. I like SSH personally. And that is a convenient way to connect to your Spark because there's going to be network services that are running on your Spark, and you can use SSH tunnels to connect securely through SSH, and it's encrypted to services that otherwise would be a little less encrypted. And so, it's like you need your device's hostname or a way to get to it from the network in a browser. Here I'm just sitting at my Spark using the console and browsing the build.nvidia.com/Spark website, which you can do even before you've got a Spark, so that you know what you're getting yourself into. Here I am sitting at the Spark console. If you're sitting at your Spark console and you go to localhost 11,000, this is what's running on your Spark, but it's not listening on your network because this is not an encrypted connection. It's just localhost, development, that kind of thing. This is the magic of SSH tunneling. This is why SSH is so fun and exciting. And when I switch to, my Windows workstation, and I'm using the tray application or my SSH tunnel with my SSH program, SSH is built into Windows, Mac OS. I'm able to use localhost 11,000 on my local workstation, but it's forwarding that through SSH tunnels to the Spark machine. And so like Nvidia, knowing that a lot of developers probably aren't familiar with this concept of like using SSH to do network tunneling, secure encrypted network tunneling, might not be familiar with that. So they spent the time and the energy to build the tray application to do that. It's not as complicated as I'm making it sound. I just want you to have a crystal clear mental map of what's going on in case you don't, because it's very important for everything that comes after. So this is the default DGX dashboard, and this will show, hey, there's an update, and you should definitely update when there are updates. It shows you the consumption of system memory, and it shows you GPU utilization. As you go through the fun here, one of the things you discover is sometimes when you're playing with models or you're running containers or containerized workloads, or download this model and try that model, they don't always let go of the memory that they're using. And so you can pop open a terminal. There's several different ways to fix that, but this will show you an idea of system memory and how that is changing over time, and also the GPU utilization. Now I mentioned, Jupyter notebooks. We'll get to that, but the first thing that I want to do is make sure that Visual Studio Code is connected and that it's available. And that's one of the things that the Nvidia integration with the tray application provides. So we want to open the sidebar here, hit the gear, and then go down to the configs icon here, which is easy to miss, and then local config, hit that, and then we're editing the YAML directly because no one can be bothered to make a reasonable UI for these sorts of things. We're going to put the UI, the IP address for the Spark, save that, close it, and now it should be functional. Llama Spark, yes. Let's see, what would we like to do? It's like, try asking to continue to make this more readable. Original, refactored. We've refactored it with loads more comments to make it more readable. It's like, oh, sorting algorithm. Which one is this? So this is continue.dev, and it's like now we're vibe coding with gas or tokens, as it were, or the little model toy factory, the toy AI factory on our desk is running. Now imagine, again, in our 1 to 200 watt power envelope. Now imagine this at scale. GB300 NVL72. Yeah, it's a fun, exciting times. Okay, let's do our Jupyter notebook next, because it's a different interface. Like, this is Visual Studio Code. This is great if you're a programmer. Check out Aider if you're just getting into this. Like, you're in for a treat. But let's do Jupyter notebooks next. For Jupyter notebooks, if you're just getting started, you're in for a treat. There's a lot of fun, exciting things. Jupyter Lab is built in. This is going to use my home directory for a working directory by default. I'm going to hit start on this. Understand that, part of what's happening under the hood here is Docker and Docker containers. A lot of the time, not always, but Docker is also installed on here, and so you can set up containers and do sorts of things like that. I'm going to give you a quality of life command while we're waiting on this to start. usermod-a-g docker, and then your username that you chose. You're going to want to run that as root, and that will give you the permission to be able to do things like Docker PS, although I'll have to relog in. Okay, once that's done initializing, we're just going to hit open in browser. And here is our Jupyter notebook, and we can, create a terminal. We can get, this is like interactive documentation. You build the code, you build the documentation. This is more of a programmer's interface for like researchers. Increasingly, If you're using R, doing stats and Python development in general, Jupyter Notebook stuff is the way to go because it can be living documentation. You can build a graph or something around a data set or set of graphs and give the folks that are interacting with the data set controls to explore the data set or change the graph or toggle things. And so the documentation and the actual code for doing stuff with it are one and the same. They become one and the same. So this evolves. This is like the evolution from, books and printed material to visual media. So this is like an evolution from code and documentation living as separate things to they live together. And this is really awesome because the code is the documentation, the documentation is the code. That's misleading a little bit, but Jupyter Notebooks are really fun and awesome, exciting things. So if you'd like to follow along, this is the DGX dashboard, like getting started, but they take you through it's like testing, with a sample AI workload. It's like we're going to create a new notebook, Python 3, and then we're going to paste in the following code. And this is going to pull in Stable Diffusion, Base 1.0. It's like Babby's first thing. A cozy modern reading nook with a big window, soft natural light, photorealistic. And the negative prompt is low quality, blurry, distorted text, or watermark. And now we just run this. Now it found the GB10 with a capability of 12.1, but I don't have the thing to do that, but it is going to fetch 19 files for me. So, yay. It's torch. It's getting torch. If you're a Python developer, this is old news for you. But if you're just, it's like, how am I on-ramping myself into our wonderful AI future? Congratulations. Python is a very easy language to pick up, and the model that we just installed, Llama GPT OSS, can teach you how to use the Python and do programming and stuff. So fun. You can just talk to it, not through this, but through the web UI. And so there you go. There is image generation. Now, setting up networking and 2 Sparks, you get into something else called Nickel, NCCL. And this is the same library and the same software stack that Nvidia uses at scale with the giant AI factory. 72 GPUs are just the same as 2. It's getting a little beyond what you would get into for this video, but I will be using both of my Dell Sparks for future videos for running the jobs that require 2 Sparks. What I'm trying to explain is that because we can do inferencing, which is more on the code side, and because we can do image generation, which is more on the compute side, and because we have networking, like we have all of the major components that exist in very large AI systems available in our very small GB10. So as you are working on this system, your learnings will scale to many other much larger systems. And I would point you to, build.nvidia.com/DGX Spark, because they have a ton of stuff that is available in terms of resources and learning and understanding how these things fit together. The Nemotron models that Nvidia offers in their partnership with Mistral are not to be missed. These are frontier models. We are at the frontier of computer science. Even randos like me are able to do things that haven't been done before, and something vaguely meaningful, and you can quantize a model, you can run it. So if that sounds exciting, check out our other content. I don't just do AI stuff, but AI stuff and like the frontier of where we are and how it can reshape humanity. Obviously, it's very exciting. And I'm Wendell. This is level 1 techs. And if you're new here, welcome. We have a forum, user community, lots of people in the community doing lots of fun, exciting things. We got some interesting stuff on Hugging Face, and it is because we have access to hardware like this, and because folks like you that are interested in this are hanging out. So come hang out with us on the forum, check it out, check out the stuff that we're working on. Love to have you, love to entertain questions, love to play what if, and if you are thinking about picking up one of these, especially like research context, students, college students, these are great for college students, for learning the stack and learning the integration and tying things in. If I could leave you, one special thing that I'll leave you with for a college student, and that is NanoChat. Check out NanoChat. So the things, like the mindset that started ChatGPT, one of the minds of ChatGPT has given us NanoChat, and it's like, here is a pedagogical resource that you can learn from and start with, and that is NanoChat. And NanoChat will run and train on this platform in a reasonable amount of time. Now, if you're into nuts and bolts and following all of our other content, you'll know that I've reviewed several other Nvidia DGX Spark configurations, including the one from Nvidia themselves, which is currently in last place in terms of thermals, but also very quiet, basically dead silent. Dell's design, I was a little concerned because their physical design is very similar to Nvidia's. But as we can see from the performance benchmarks and the numbers, if you're into the numbers game, come to the forum. There's more information in the forum thread that goes with these. The performance of these is a little better than Nvidia's design. And I think that's because Dell's been a little bit more aggressive with their fan profile, even though these are very similar, in terms of design, internal layout, that sort of thing as Nvidia. It's not the gold version, obviously. But it seems like the airflow through the front is a little more permissive, and the fan profiles are a little more aggressive when this thing wants to run and use a lot of power. One of the things that I saw was like the ConnectX 7 NIC throttling a little bit when the rest of the system was fully loaded. But with this system, using the CUDA cores for compute and the ARM cores for CPU-based compute plus networking activity, yeah, we can sustain 200-ish watts and get pretty reasonable performance from the platform. Definitely well within the envelope that Nvidia set, and definitely not seeing a situation where instability creeps in under full load, which is great to see because not everybody, especially people with the Nvidia, like the gold design, were experiencing that same level of stability. I mean, at the same time, Dell is a little conservative too. They're not juicing the platform to squeeze every single little bit of performance out of this that they can. So there are certain Spark platforms that will perform a little bit better, like that are pushing the clocks a little bit more. But I think what Dell has done here is reasonable, and more reasonable than what Nvidia did with their solution, because these can get a little louder, but they do a little bit better with cooling and are perfectly stable. So that's nice to see. The last thing that I'll mention, which is a very off-label use, is Steam. Gaming? Yeah. You wouldn't buy one of these to game on, but it's ARM. And there's a project called Box64, and Box64 does emulation. And so you can install Steam, and you can set up Box64. I've got another guide for that on the forum. If you want to do that, you will be able to game on this platform with ray tracing and high settings, 1080p. You can do over 100 FPS in Cyberpunk. You can do over 180 FPS with multi-frame generation and all of the features. And it's like, well, that Cyberpunk wasn't built for the ARM platform. It wasn't designed for the ARM platform. Multi-frame generation probably hasn't even been tested on the ARM platform. And you're telling me all of that works? And the answer is yes. So if you're interested, like if you're a developer and you develop games and you want to do testing, then Steam with x86 emulation, because none of those games are designed for ARM. That is on-the-fly x86 emulation, and that works astonishingly well on the DGX Spark platform from Nvidia. Shockingly well. Probably enough to send waves inside the companies that are making x86 processors, because it's so good. There's a very off-label use for this platform, not even something Nvidia considers. It is maybe of interest to viewers of this channel, and maybe of interest to game developers and folks that are working on a platform like this, because this is, it's like roughly 50-70 levels of CUDA cores and performance. Now, it doesn't have VRAM, it's LPDDR5, which is considerably slower than GDDR memory, graphics memory, but it's still fast enough to be quite fast at 1080p in a lot of modern and AAA games.